We've looked at parabolas before in standard form. So a lot of what we're looking at now is identical. However, there are some new twists and turns that we need to look at. So first of all, remember that the formula for a parabola in standard form is y equals a times x minus h quantity squared plus k. It's important that you have that memorized. We're going to ask you what a is. We're going to ask what h is. We're going to ask what k is. So make sure you know all of that information. First thing we do is decide if the parabola opens up or down. And then that corresponds to whether it has a maximum or minimum value. And we determine that by this number a. If this number a is a positive number, the parabola opens up, therefore has a minimum. If a is a negative number, the parabola opens down, therefore has a maximum, as you can see in front of you in the formula sheets and what's on the screen. Next order of business is decide whether the parabola is normal width, and the way you do that is take the absolute value of this number a. If that equals 1, it's a parabola of normal width. If the absolute value of that number a, whatever that is greater than 1, it's narrower than usual, and that's going to mean more than just what we've learned it to mean, that it's narrower. It's going to mean something else. And then if the absolute value of that is less than 1, that's wider than usual. And we can call them vertical stretches for the narrower and vertical shrinking for the wider. That's fine. And the vertex, as we already know, is HK. The opposite of what's in parentheses with x is the x value of the vertex. If it's not in parentheses, don't take the opposite of it. That represents the y value of the vertex. The equation for the axis of symmetry is essentially found inside the parentheses. It's this variable x equals, and then the opposite of the number that's in parentheses with x. Now, when you know it has a maximum or minimum, all you have to do is look at the y value of the vertex. That's what that maximum or minimum is. There's a couple other things we're throwing in today, and one of them is called the focus. Focus we will get to in a second when we look at the geometric definition of a parabola. Just quickly, the geometric definition of a parabola says you have a line and a point not on that line. So again, you have a line and a point not on a line, and the parabola is the set of all points equally distant from that point and from that line. That point has a name, it's called the focus. We will need to know how to calculate where it is. That other line has a name, it's called the directrix, and we will need to calculate the equation of that. For the focus, if you look very carefully, the vertex and the focus are both on the axis of symmetry for a parabola that opens vertically, up or down. So the x value of the vertex is not going to change. What's going to change is the y value of the vertex. And we are going to add something to that y value of the vertex. What we're going to add is 1 over 4 times a. Not 1/4 of a, but 1 over 4 times a. And lest you forget what a is, remember a is this number in front of the parentheses. So you're going to take 4 times that number in front of the parentheses and then take its reciprocal, and that's how you calculate where the focus is. Directrix. First of all, let me help you remember, if the axis of symmetry starts with one variable, in this case x, the directrix is going to start with the other variable y. So it's a horizontal line. Horizontal lines have equations y equals something. They're going to equal the y value of the vertex, but not plus this 1 over 4a, but minus the 1 over 4a. And again, a is this number in front of the parentheses. That's how you calculate that. And actually, if you're curious, then the vertex is the midpoint from the line we draw from the focus perpendicular to the directrix. So that's looking at a parabola. We need to look at one more thing, and that is the eccentricity of a parabola is 1. Eccentricity of a parabola is 1. Eccentricity is calculated by the distance from the focus to any point on the graph divided by the distance from that point on the graph to the directrix. Well, since the geometric definition says the distance from any point on the graph to the focus has to be the same distance as that point measured perpendicular to the directrix, anything divided by itself is 1. So therefore, The eccentricity of a parabola is 1. Remember, eccentricity is essentially measuring the curvature of that shape compared to a circle. All right, well, what we haven't seen before is horizontal parabolas. So this parabola can open to the right or it can open to the left. First of all, you know that because it's x equals, it's not y equals. So look at the variable that's by itself. Y equals, y-axis goes up and down, our parabola opens up or down. X equals, x-axis goes left or right, so my parabola goes left or right. Now, some things are still true. If A is positive, that's going to tell us which way it opens. But in this case, if it's positive, it opens right instead of up. If it's negative, it opens left instead of down. Same thing is true for the width. Absolute value of A equals 1, normal width. Absolute value of A greater than 1, narrower than usual. Absolute value less than 1, wider than usual. And vertex is still HK. But before you think that's simple, before you think you've got that wired, look at the equation where H is and where K is. H is now this number behind the parentheses. Before, with a vertical parabola, it was the number inside the parentheses. K is now the number inside the parentheses. But it makes sense because y is in the parentheses. The opposite of the number with it is the y value of the vertex. Therefore, h needs to be the x value of the vertex. And if you look, the variable x is by itself, and h, they're at either end of the equation. Those two go together. The ones inside the parentheses, those two go together. So k is the one in parentheses with y. I know when you have vertical parabolas, you're used to just grabbing hk from left to right. Please don't confuse that. Now, my focus has to stay inside the little bucket, so to speak, if you call the parabola bucket. So that means I need to move it left or right. Before, with the vertical parabola, we had to move it up or down. It's still 1 over 4a added to something, but since we have to move it left or right, we're going to add that to the x value of the vertex. X value of the vertex, 1 over 4a. All right, let's talk about the axis of symmetry. That equation is essentially found in the parentheses. Y equals the opposite of that number. Again, focus, 1 over 4a, we add to the x value because we have to move it left or right. Now, if my axis of symmetry is y equals, my directrix is going to be the other variable, x equals in this case. And it's going to be the x value of the vertex minus 1 over 4 times a. Again, the vertex is still the midpoint of the line segment from the focus perpendicular to the directrix. And what has not changed is the eccentricity of the parabola is still 1. How can you tell you have a parabola in general form? Well, all of the conic sections in general form start out with ax squared plus by squared plus cx plus dy plus e equals 0. For a circle, remember, the coefficient of x squared and the coefficient of y squared had to be same number, same sign. How can you tell it's a parabola? Simple. Either a is 0 or b is 0. Translation. Either x squared is not in the equation or y squared is not in the equation. One of those two is missing. If both of them are there, could be circle, ellipse, hyperbola. If one of them is missing, the y squared or the x squared, it's a parabola. Whichever one is missing, solve for that variable. So if y squared is missing, we want to solve for y equals vertical parabola. If x squared is missing, we want to solve for x, horizontal parabola. All right, that's a look at the formulas for parabola.